Okay, so now let's take a look at our Kubernetes cluster and let's deploy TimesTen in it. Here we are just at a standard command line. We'll just verify that we actually have access to our Kubernetes cluster. We'll just run the get nodes command, which will show us the physical or virtual machine nodes that make up our cluster. And we've got a pretty big one here. There's no TimesTen running in it, but the Kubernetes operator is running. Now to deploy TimesTen in the cluster, we can start with a simple little YAML file. And we're going to go through just a very simple example with no bells and whistles, just to get started and show you how it works. In this YAML file, we're going to create two objects. One of them is a Kubernetes secret, and that secret is going to contain a couple of different entries. When you deploy TimesTen using the Kubernetes operator, you can provide TimesTen with a number of different metadata files which you would like for TimesTen to use to configure the databases that it creates. In this case, we're going to use two simple ones. We're going to tell the Kubernetes operator that we want to create a particular admin user, or user with lots of privileges in that database, whose name is Scott and has Tiger as his password. And we also are going to create an initial schema in that database. So we're going to create a table called scott.imp with a very simple schema here. And you could create as many objects and sequences and PL/SQL procedures and other things, whatever you'd like to initially deploy in your database here. So we put those into a Kubernetes secret just because we've got a password in here, right? So we would like for that not to be completely visible. So that's one object that we're going to create. The second object we'll create is a TimesTen Classic object. Now this isn't something that Kubernetes knows about out of the box, but because we've installed the TimesTen Kubernetes operator in our cluster, that's added a customized resource definition, a CRD, which has told Kubernetes that there's a new kind of object in town and it's called TimesTen Classic. So we're going to create a TimesTen Classic object. We'll give it a name. We're going to call it Demo1. And then we're going to define some basic details for what we want to have deployed. Anytime you create a TimesTen Classic object, we're going to deploy two pods arranged in a stateful set. Each of those pods will run TimesTen. One of them will contain the active database, and one of them will contain the standby database in an active standby pair that's replicated. So that'll happen automatically, but we do have to tell it a few things. We need to reserve some persistent storage, right? We are talking about a database here, and so we need a place to store that database. And so we have to tell TimesTen, in my case, that we want each of those pods to have access to 50 gigabytes of storage in which to store its database. And we're going to use a Kubernetes storage class called OCI in order to, as a way to get that. That's the type of storage that we want Kubernetes to provide to us. And the values for that, of course, depend on your cloud provider or your Kubernetes environment. I'm running in the Oracle Kubernetes environment OKE, and so the storage that's available to us is under the storage class name OCI. So now we've got some storage. Of course, we have to run an image containing TimesTen, and as part of the installation procedure, you would create a container image containing TimesTen and some components of the operator, and you would store that in your image registry, whichever one you're using. In my case, I have an image predefined called SAM TimesTen image, which I created during the installation process. Because we're asking Kubernetes to go run that image, of course, we have to give Kubernetes the ability to do that. And just as with anything you run in Kubernetes, you use an image pull secret to do that. I have a secret called SEKRET, which I've defined, which sort of encapsulates my authentication to the container registry. So basically, we specify that, and that lets Kubernetes log on to the container registry as me and pull that image if it doesn't already have a copy. And finally, we tell the TimesTen Classic object, we tell it where to get its configuration info, and we created this secret called demo1, and so now down here we'll reference the same thing. We'll just say get this, use this demo1 secret as the way you configure this particular active standby pair of TimesTen databases. So that's it, not too hard. And now let's just run that file. Now with everything in Kubernetes, you use the kubectl command. I don't know how you're supposed to pronounce that. I'm just going to say kubectl create-f demo-yaml. And that will have Kubernetes go through that YAML file and create those two objects, right? It's going to create an object, a secret called demo1, and it's also going to create a TimesTen Classic object called demo1. So Kubernetes is off now. It knows that we want to create a pair of TimesTen databases replicated. It knows everything about it. The operator that TimesTen provided is going to be invoked automatically by Kubernetes, and it will walk through the process of setting that up. First thing it's going to do is it will create some other objects. Right, so first we can look and see that there is a TimesTen Classic object in Kubernetes called demo1, and Kubernetes actually knows what a TimesTen Classic object is, and it knows that it's initializing, so it's not up yet. Under the covers, we also, the TimesTen operator also automatically created a stateful set called demo1, and that stateful set is what Kubernetes is going to use to actually create the two pods that are going to run TimesTen and allocate persistent volumes to them. And it looks like both of them are up. 2 out of 2 are up. We could also look at those pods directly. And we'll just look at all my pods. And we'll see, we've got a few we don't need to worry about today, but we've got this demo1-0 and demo1-1. And those are the two pods that we are running, that the Kubernetes operator is in the process of setting up using TimesTen. And of course we can see that the TimesTen operator itself is running here. And it's actually the one that's doing all this work under the covers. Okay, so now we see that everything's in the process of coming up, but if we look at the status of that TimesTen Classic object, it is already up. Okay, so now look, the state is normal, and that means that the TimesTen, not only do those pods both exist, but TimesTen is running in both of those pods. One of those pods has an active database. Well, we've created an active standby pair, replicating data from one database to another. At the moment, the active database is the one in pod demo1-0, and it's been up for a few seconds. If we want to see more details of what happened, excuse me, as things come up, as the operator was putting all of that together, it created a bunch of events, Kubernetes events, and we could look at those to see what the status of things are. And if we look at those events, we can see the entire process of everything starting up. So we can see that there was we can see the TimesTen agent in each pod coming up. We can see the TimesTen itself in those pods coming up. We can see that in the demo1-0 pod, we decided that was going to be the initial active database. So we created a database there, loaded it into memory. We've started up the replication agent in it, etc. Then in this demo1-1 pod, that's where we're going to put our standby TimesTen database. Similar, we can watch the database there come up. We can watch the replication come up in this, with this one as the standby versus the active in pod demo1-0. And when we get the active up and the standby up, and they both are healthy, then the TimesTen Classic in object called demo1 as a whole is now up and running and normal. So now we have our active standby pair of databases with the users and schemas that we define already in it. Now if we want to use that, we could just use, easiest way to do it just to look at it is we can use kubectl exec. We're going to create an interactive shell in that demo1-0 pod. That's the one that's running the active database. We'll put it in the We want to look inside of the TimesTen container in that pod. And let's just run su command to log on as the Oracle user in that container. And that'll give it, so now we're running at a command prompt inside of that pod we just created that runs the active database. And we could just run the standard TimesTen TDI SQL command here to access that database. And now we have our database up and running. Well, we could look at that scott.emp table that we created. There's nothing in it, so we could insert a row in it just for fun. And the database is up and running. And we could then, by using TimesTen basic SQL facilities, we could then verify that this is in fact the active database of this active standby pair. And you could do whatever you wanted to at this point. So now let's get back to where we were, and now let's look over at the, just for fun now, let's look very briefly over at the standby database, which is running in the demo 1-1 pod initially. We'll do the exact same thing. And over in that pod, we could look at that demo 1 database. See that the row that we inserted in the other pod is really here. And we could verify that this is the standby database, right? This one's read-only, the other one's read-write. If I try to insert data here, of course it won't work because we're running on the standby. Now, of course, so this demonstrates the process of setting up a pair of active standby databases in Kubernetes using the TimesTen operator.